Today we'll talk about this, SCMI server in secure world. What is it, what it's about. We'll do a brief introduction and then we'll go into the details. When it says SCMI server, firstly, what's a CMI? That's what it is. System controller and management interface. That's an ARM specification which allows you to talk to a power coprocessor that's sitting anywhere, secure side, maybe on a microcontroller, maybe somewhere else. It's just a interface specification. And so the purpose of this project, and this is a Linaro run project, was to show that you could actually have an SCMI specific server that runs on the secure side as well. We do have a reference implementation in ARM of a server that runs on a microcontroller, or an SCP that runs on a microcontroller. We wanted to have a version of it that runs on a secure side as well. And that was a project that was over here. So this can be, so we have the following protocols supported right now. So that's the specification protocols. The work is ongoing to support all of them, but we have not supported all of them, at least in the work that we have so far. But on the specification, you can have we have a base protocol, which is basically for discovery. And then you have power, system power. System power and power are different, because system power is mostly for system suspend, system resets, and so on and so forth. Then there's a performance domain that you can use for CPUs. You can even use for your devices if you want. And you have your clocks, sensors, and reset. And reset is basically for peripheral resets, not your system reset. The system reset comes as a part of your system power protocols. And if you want more details on the specification itself, you can go to this link. There is a talk that we'll have after this session that will cover in more details about the upcoming features of the next SCMI and what we have done extra. So look out for that. So why do you want this in the secure world? Frank reason is we dreamt of this SCP that will run on a microcontroller, but the reality of life is that there are platforms which are more resource constrained. You don't want to have a microcontroller in every platform. That shoots up the cost, that shoots up the power budget, and your BOM footprint and area as well. So we do not have a dedicated microcontroller in most platforms. And in some platforms, you do have a microcontroller, but you have only one channel to access that microcontroller. And that can be either a secure channel or a non-secure channel. And then the final thing is that if you have just one channel, it has to be on the secure side, because that's where your security aspects play out. And you want, because you are accessing actually secure resources like clocks and power domains, which can be modified, and you can tweak around with the system and put the system into unstable states. And if you have just one channel, better to have it on the secure side than the secure rely on the non-secure side. So what happens over here is that on the Linux kernel, and this is a very small block diagram, thanks to Vonso for that, what it does is it routes all the requests for your GenPD, clocks, reset. These are just 3 examples that we have built in right now. You can have the whole host of SCMI protocols on top of that. It talks to the SCMI driver, which then talks to the SPCI driver, and that's a typo, sorry for that. SPCI driver. Right now we have the SPCI driver that's in a prototype stage, so we can even depend on a mailbox that talks SMCCC for an SMCCC dispatcher. So that's an intermediate state till we have an SPCI finalized out. So then that goes to the dispatcher and it goes to the secure side. So on the trusted side, what you have is a secure thread that runs, and on top of that you have an SCMI server and the PMIC clock driver resets, whatever. But anything that you see above the secure thread is all a part of the SCP standard code that is there upstreamed in the ARM SCP GitHub. So if you look at the SCP GitHub, we are trying to reuse all the code up, and the SPCI and the secure thread perspectives are something that we are creating for specific OSs like Opti and so on and so forth. So in such a scenario, you can notice that since the secure side controls all of your power resources, then the secure side actually appears as a sort of pseudo SCP or a SCMI server to your non-secure side. So it has the same semantics as with a microcontroller. Everything on the non-secure side appears the same. There is actually no difference. The non-secure side is none the wiser whether it goes to a microcontroller or on the secure side. And that's what the SCMI server on the secure side is all about. And for further details, I'll hand it over to Vonso.
Thank you. And maybe we can also add that having this kind of solution, we can mix a power coprocessor and this one in parallel, depending on the resource. Because you don't know where the server is running, you can just multiply and parallelize them.
And we'll have all those configurations in the next session that we have. We'll show different mix and matches of what we can achieve.
Yeah. So for the prototype that we are running, for now we are using OpT, and especially we are using the OpT thread context as an entry point to run our server, our state machine. And also, so yeah, that what we need is really this kind of context where we run this simple state machine. Yesterday there was a presentation about the SCP firmware, which explained how this is working. It's made to be simple and based on events, so you don't need a lot of modern or evaluated feature. So we just need this to be able to exit and come back to continue for the next event. And related to this, we also need an entry point in OpT. So yeah, we have a mailbox. So everything is based on mailbox on the SCP. And our goal was really to maintain the same kind of architecture and design. So we have created in the SCP firmware, in the SCP server, a mailbox interface, which is connected to OpT and the SPCI protocol. So from a server point of view, it's just like the mailbox, and we're even using the same memory layout as hardware mailbox. So for them, it's really exactly the same. It's just how we are accessing to the message. So for that, because we are using the OpT interface, and we are not really an OpT trusted application because we need to access to the core part. So we are parsing, so the OpT message are parsed, so we can split and make the difference between a normal and standard OpT interface, OpT message, and a SCMI server message. So we can catch the SCMI message and enable and call our server. All the implementation, as I explained, is based on the SCP firmware, so just to reuse, to share the code, all the protocol. We don't want to develop a new SCMI protocol. Apart from doing new bugs, we will not get any benefit. So we are reusing everything. And the main advantage is that because all have been partitioned between the framework, the module, and the platform-specific configuration, it was quite simple. We mainly need to create this OpT framework specific entry point, which was mainly the entry point of our server and the thread. We are using a unique thread context. Yeah, that and the last point, it's about integrating. So we are in the core OpT part. So yeah, the SCMI server prototype that we are working on. So we have used the OpT as the first secure environment because that was mainly the first request that have been raised during our study. But the goal is not to be only run on this OpT, but to be able to run in TFA and TFM. We haven't started that, or even as a bare metal. With the SPCI and the SPM, we can have your own context and just run that as if you were running in your own bare metal, secure environment. But the goal is really to reuse the same code every time and only to change the low level. So we will not go in detail for the TF and TFM mainly because we haven't started that yet. We will have some discussion during the week to see exactly what are the constraints, if they are similar to OpT or if we have different constraints and problems that we'll have to fix. Yeah.
So have a bit of a background to this project. So initially you had considered running the SCMI server in an application, in a TA, and then it was pulled into Securial 1. Yeah. I'm wondering, since we discussed earlier in the day about adding support for Securial 0 partitions as a special kind of a TA in OpT, and one of the things that the Securial 0 partitions require is some kind of device assignment that here is a range of MIO regions that you need for your drivers. So, could you elaborate the reasons why it couldn't be a TA, keeping in mind the other work that's going on now, or would it still continue being in Securial 1?
I haven't a lot of detail on that. Maybe the main point is because we are not using the default opt interface in our message.
Okay.
That's one point.
Mm-hmm.
And the other point is that we need to have access to some hardware resources.
Okay.
And
all right. But like just to kind of probe a bit further, are those hardware resources shared with Opti, or these are like new drivers that Opti typically won't access, the Opti kernel won't typically access?
so yeah, maybe you can give some detail, but we have some shared resources right now. So
Okay.
Well, actually, the SCMI server, which is built from the SCP firmware implementation, defines drivers in the SCP firmware module way. And on these SCP firmware modules, we have some backend drivers that are the drivers that are currently used by the Opti. So we have something on the ARM-V7 machine. And for example, we have like a clock, so there's a backend clock driver into the Opti that is used by the secure world for the secure resources. And the SCMI server just calls this backend driver when it needs to enable some clocks. And currently, it's up to the backend driver to monitor the dependencies on the resources and the fact that there are requests from the non-secure world. So it's the same backend driver, and the SCP firmware only is there to get the message from the non-secure and to formalize.
Sound like it should be possible to maybe say para-virtualize this driver from the SCMI server's perspective, which is because like if we can put it in a bare metal partition when 8.4 comes along, then I'm just saying like if we start with that today as a Securial 0 partition, and then 8.4 comes along, it just continues being a Securial 0 partition, then it would be a better migration story, right? There would be less change. That's purely there.
I think that's ideal, but I can see the limitations at the moment. The difficulty is a lot of the Opti contains a lot of services that are built into Opti and are not available to, TA to TA communication. So, ARM's interested in doing some Opti exploration to try to make a cleaner separation there that will unlock that kind of use case. And when that, with that work and plus SPCI, then I think we may be able to achieve that architecture. And I think in the longer term, that's where we'd like to go.
Something to keep on the table.
Yeah.
That's the thing.
Just as a thing, that this is the first attempt. And this is not the final product.
Yeah, that's exactly what I'm trying to say, that keep that window open, right, like in the future, possibly. Thanks.
So the SCP firmware, so we have a GitHub. Right now we have 2 development branches, which maybe some part have been merged or pulled for the main branch, but one, it's about mainly working on the power domain, enabling the power domain, the clock, and the performance domain. And also this prototype for using the SPCI Mailbox. And the other one is more about, so this is based on a virtual platform. So we are faking some clock resource. And we have another branch which is more about enabling that on an ARM-7. So we want to work both on ARM-V7 and ARM-V8. And that's on a real hardware. So that's why we face the problem of having a real hardware resource to manage, either for the non-secure or internally for the secure, and all we have been able to discover some booting, ordering problem, and so on. So we have both. One is really about enabling the protocol, and the other one is really to make sure that on a real platform, we are fixing everything. It's there. At the end, our goal is really to make everything merge in the GitHub. We don't want to maintain some out-of-the-tree patch. So, and then, so all the change that have been done. So, we have created this interface between the SCP framework and Opti for the log. We have right now a simple memory allocation, which is based on the default one, but we'll probably have to connect with the OPTI memory allocation interface. Yeah, that's something we haven't really looked at. It's about the speculative execution, and because we are moving from both sides, we probably need to make sure that the share of this memory and the message don't open some, I don't know, some problem. So as I explained, yes, we have created an OPTI platform, which is quite simple. I mean, if you look at the code, mainly because right now we are, for example, we are not managing IRQ, we are monothread. So it's few, maybe dozen of line of code, no more than that. So yeah, so we have disabled the multi-threading because we are not supporting that right now. We have disabled the notification because we don't have any mechanism for now to be able to notify the non-secure world from an event coming from the secure world. So that's something we'll have to work on. And we have, yes, so we have created the mailbox module, as I explained, which is mainly just where to find the message, but we haven't changed that in any way. And then, yeah, the other point was to make the connection with the message parsing in OPTI and how to catch that and schedule our own thread context. But no more than that. I mean, the code is really simple on that part, which can be a bit surprising at the beginning. And that's work. Just, yeah, how accessing the SCMI server from Linux. So as explained before, we already have a SCMI driver in Linux, which populates some GenPD, clock, reset is not yet there, CPU FREC, and hardware on device, depending on what is discovered on the at boot. Right now, everything is working with the interrupt mailbox, the hardware mailbox. And we are looking at adding the SPCI driver supporting this and the SMC Mailbox as well. But that's currently not yet there. We have a prototype with SPCI. We haven't started with the SMC Mailbox. That's probably something we'll have to look at. I mean, yeah, okay. And yeah, the goal is to be able to support all the transport layer, the hardware layer, in parallel. I mean, we don't want to enable only hardware mailbox or only SPCI, but we want to be able, the goal is really to be as flexible as possible for the different platform that can use it.
A bit of the current status. So, well, as Vincent told, development were made on the virtual platforms, on the VFP, made some things on the QEMU with some virtual clocks just to make sure that we have some things that can easily be shared with people that do not have specific hardware. And there were development also on this ARMv7 STM32MP1 platform where we have real hardware, real clocks and resets that are used in the secure world and that must be shared with the non-secure world thanks to this SCMI thing. So for current progress, Vincent enabled several SCMI protocols on the virtual machine through this SPCI mailbox thing. That is some on-progress work by Arm and Linaro. And for the QEMU and the STM32MP1, we explored both the SPCI layer and also an SMC-based mailbox based on the patch from Penfeng. Oh, it's not Penfeng, it's Peter. I shouldn't pronounce his name, I will pronounce it back. They have SMC mailbox-based patches that are being reviewed in the kernel. So, well, currently we use the patch version 2 that is 2 years old, and just so that this summer the SMC mailbox patches were in progress and being reviewed and updated. So it's not merged yet, but at least give a basic SMC mailbox, so we have those several mailbox interface we could use. Mainly, well, let's just talk about this. And the goal is to have, of course, everything upstream and available. So in the Linux kernel, where almost everything is there, and the latest SCMI specification is being merged currently. So all that's brought by the SCMI v2. This SMC Mailbox in the Linux driver is some work ongoing. So I put that patch v3 is available. At least patch v3 was released like in July, and they're up to the patch v7 now because it's progressing. It's active reviews. And we have some changes we need in the SCP firmware to have these reference implementations that could be used in a coprocessor as well as in a secure world, being an OPTI or, as we said before, some TFA or some bare metal, whatever. So the idea is that everything that needs to be updated to support this in the SCP firmware is also merged. So we work with the SCP firmware team for that. And last is, well, currently ongoing work, all the work on SPCI, which is written correctly here. SPCI, so it's still work ongoing, so it's not merged yet for sure, but when it will stabilize and mature, I guess it's some interface that will come because it's needed by the latest ARM V8 releases. And also in the OPTI, since we want this SCMI server to be in the OPTI, there are a few changes needed in the OPTI, but the idea was just to reuse, to have the old OPTI building sources that comes from the SCP firmware. So, well, actually I just wrote that in the OPTI, we would like to fetch the SCP firmware sources, configure and build them, and just have had a discussion with those OPTI guys and Jens that just, well, just told me that we should maybe find another solution, but the idea remains to have the same implementation. Wherever we'll fetch some Git submodule or wherever we just clone the code and make some manual synchronization by release, I guess the idea remains to have a single implementation and bugs fixed from this single implementation that remains the SCP firmware Git repository.
Can I interrupt, Etienne, just while you're on that page? Around this SMC mailbox, is that a specified interface, or are the patches the specification effectively for this interface? Is it? I don't know. Is that an evolving thing? Is first part of my question. The second part is, once that's complete, is that going to be upstream, and is there a risk of that becoming a de facto standard which disrupts the future SPCI work?
Okay, two answers to this. For the SMC mailbox, that's something that's been developed not in synchronization with this effort, so that's being driven typically from NXP and a few other companies, and that has a few other implications. SCMI is one of the users, but that SMC mailbox can be used by other users as well. So that has a different connotation as compared to the SCMI path as well. So what our purpose is that we will use the SMC path for now, and then 8.4 onwards, whenever we have the full-fledged SPCI, etc. running, you should be able to use the SPCI path as well. So the focus is from our side is that the SMC is now at least a prototype solution for now, because or using the SPCI prototype that we have, either one is a prototype solution, but eventually we should move to SPCI. But the SMC mailbox is something that is there in the kernel being merged by NXP and the other people, and that is going to stay. So if somebody comes and somebody says that I want to use that mailbox, they can, but the problem over there is that there are no definite function IDs over there, so people will have to use their own SIP IDs and have their own hacks all around the place if they want to use that. So that's not something that's feasible for anybody to use, at least as far as SCMI goes in the long term. I mean, it's going to become an unclean solution.
Who are the other users of that mailbox protocol, like apart from SCMI? What, like any examples?
I have no idea.
Maybe I can tell, I can tell because we've looked why NXP pushed this. Actually, I think they pushed this to have some SCMI basic services available in trusted firmware A. So their intention was to use also a mailbox-based interface, which is also SCMI. But SCMI mailbox is just to have a basic mailbox based on SMCC rather than SPCI, which is a really more complex thing. And even, well, you said that SMC mailbox, maybe we will get rid of it once SPCI is ready. But when we consider these ARMv7 platforms, adding the SPCI layer in the monitor just increase the size of the memory footprint. So maybe it could be an argument to go into some more light mailbox services if we don't really need SPCI, because SPCI is really about managing secure partitions, and on those old things we only have one partition.
So if there is complexity associated with the SPCI, well, and I'm talking about the latest spec of the SPCI, then I think the first attempt should be to reconcile that into the SPCI spec. That's something which we are developing, right? Because the overall intent is to basically move vendor-specific code into secure partitions going into the future, right? And it would be good if partners start seeing SPCI as the migration path, right? So
I agree. Having one common interface, whatever is the implementation,
exactly
would be nice. It's just that with current products, we see those limitations, and using this, working on this STM32MP1 platform, which is ARMv7, it's a platform where the secure world runs in the small internal RAM, which is very small. It's 200 kbytes, 256 kbytes. So it's, I mean, we can add
absolutely.
some glue, some SPCI or some code in that, but it just, with Opti, it adds some resident code, so it just, we have a very constrained memory system. So if SPCI just adds like a few kilobytes of code, it could be that it's too much for some features that we don't need, so we still need to explore both ways.
There are simplifications to the spec in that regard, so I'd be happy to discuss those with you afterwards.
And actually, we have also issues, whatever we use a SMC mailbox or a SPCI mailbox, we have common issues to tackle. So, I mean, SPCI or SMC, there's none, which is the definite solution.
Basically where I'm coming from is it's just an SMC call at the end of the day. There shouldn't really be too many different ways of doing it, right? It's not rocket science at the end of the day, right? So, yeah, but I'd like to hear and discuss with you what the overhead is, because the latest spec does simplify certain things in this regard. So maybe. But
definitely we'll follow the SPCI thing. And even SPCI, so it was designed for ARMv7, ARMv8, 64-bit machine. And we made this port with you on SPCI for supporting 32-bit machines.
Yeah, it has support for ARC32 now. Yeah. So.
Limitations and constraints. Well, currently we consider a SCMI flow where things happen, things are serialized. So when there's a SCMI request that comes in, we have to wait, it's completed, and the mailbox is released before we can have another coming in. So it's like what we call mono requests. Yeah. Also, currently in the secure mode, for example, if we have to do an I2C transfer, we cannot release, we do not support interrupts. So we cannot have we have to be actively pulling in the secure mode, because currently we don't have means to go into the secure mode, to wait for some hardware event, relaxing the CPU, like going back into the non-secure world, and waiting for some secure event to reschedule the secure thread back in. So currently, when we're in the secure mode, we're just pulling. It's pulling thing, and I guess we have to take care about whether there are some interrupts to serve and make sure that there's no race condition, I guess, in accessing some resources. Also, a limitation, specifically when using this SCMI server into the Opti, Opti has some remote processing calls where Opti can invoke services from the non-secure world. And these services are currently are based on the Opti Linux driver. So when you go through the Opti Linux driver, you end up in the Opti, and Opti is able to call services back in the non-secure world. If we enter the Opti not through the Opti driver, but through an SMC Mailbox, for example, or some SPCI drivers that is not related to the Opti driver, then all the Opti services, RPC services, are not reachable. So currently we have to make sure that all the SCMI resources do not rely on some RPC services from the Opti. So it's something to consider.
So we had the same discussion earlier in the session earlier. It's the same problem, and hopefully in the long term SPCI will solve that too. But
SPCI definitely will solve this problem, but again it would be very interesting to see how the SMC Mailbox side of things tries to solve the problem, because again we are or else we would be trying to solve the same problem in two different places, right?
If you're using the SMC Mailbox, it's a hack all over the place. So if you're using the SMC Mailbox, you've got issues.
Right.
So that's taken for granted. So you're using that, knowing that there are disadvantages. So the cleaner solution in the long term is this.
Yeah.
Well, I think even with SPCI, if you reach the Opti through an SPCI link, you won't be able to have the Opti reaching back these RPC services.
No.
So
Again, in the long term, the hope is that the secure service in Opti will be in a separate TA, which is communicated to via SPCI, and then that RPC also would use SPCI back into the normal world.
Yeah, it's like maybe designing some Opti mailbox.
See,
having an Opti mailbox, everything would go through the Opti drivers and the links. And
the way to look at it is that what SPCI is trying to achieve is that all trusted OSs have their proprietary SMC calls, which provide the transport. We want to replace that with one standard transport, which is SPCI. So the fundamental requirement for the SPCI spec is that any supplicant communication which is not specific to Opti, most trusted OSs do it. It has to cater for that. If it doesn't, then it can't work, right? So from that perspective, I'm saying that RPC communication is factored into the SPCI spec.
Okay. Oh, I agree with that. So currently, we just limit. We try to. We have to limit all resources used by this SCMI server, just to be sure that we don't enter those kind of issues. Also, well. In the current limitation, there is this notification thing that is not supported. I don't know what time it is, if we still have... Oh, we have to hurry? No, it's okay. Okay, great. So currently, notification is something that is defined by the SCMI specifications, and that allows the SCMI server to notify an agent, a client back, that some event arrived. Well, there are two main uses for those kind of notifications. Is asynchronous requests that can use a notification, obviously. And another one, which we are really interested in, is one of these SCMI protocols, which is a sensor thing, because the sensor is just there to notify that some events arise. Okay, so to support this sensor thing, we really need notification. But as currently we don't have any implementation available for the secure world to notify asynchronously the non-secure world that something happens. Actually, we need some non-secure interrupt that is available and that can be raised by the secure world. So we enter the non-secure world from some with some asynchronous event. So it's something we have to deal with. And currently, the main issue with that is to find a non-secure interrupt that is available. So we would like to use some of the generic interrupts, but they're all assigned. So
right. So am I correct in understanding that this is left as an implementation-defined thing in the current implementation? Okay. But if we were to follow an approach where the secure world donates one of its interrupts as a non-secure interrupt, it could do that, right? Like, I'm just asking, like, Okay.
We have absolutely no, we haven't spent any cycles on this side at all.
Okay.
And this is an open. So yes, thank you.
So I guess per platform, there can be like an interrupted, find, and assign because it's not used. But it would be better to have a generic same interrupt description mechanism. So, well, it's something we'll have to explore for that. Another limitation is that the sorry? Oh, sorry, Simon.
The mailbox framework doesn't support asynchronous requests.
The patches are under development internally within ARM. So today the support is not there in the kernel as well.
Yeah, next bullet was about the Cortex-A speculative execution, and we know with this speculative execution we're very efficient, but also prone to some issues regarding security flows. And since the SCP firmware was designed for a coprocessor and basically for Cortex-M-based coprocessor, the current implementation does not take into account those kind of issues. So I think there will be changes needed in the SCP firmware so that when it's built for a Cortex-A thing, there are some places where we'll have to make some specific checks, mainly thinking about this non-speculative comparison things, where we have some, or we already have some macros to handle those things, but we should implement that in the SCP firmware, specifically when building for a Cortex-A, because I guess we do not want to add those things for a Cortex-M thing. And, well, already discussed it, it's memory footprint. So on very constrained devices, the footprint of the SCMI server should be as low as possible because, well, it's just a service. It has not a lot of complex things to do, so it should be as small as possible. I think that was written. Currently, building the SCP firmware for Cortex-A with clocks and reset, it takes about 12 kilobytes of read-only memory. So it's not that big, but it's too big for what it's used today. So we have to also to improve that specifically for memory-constrained devices. And I mean, I guess the SCP firmware is very modular, so it's easy to have those modular things. But the cost is the memory that it consumes. So, I think I hit the wrong button. Yeah, and just a bit about ARMv7 specificities. I'm just checking what we've been written. Yeah, the main difference between ARMv7 and ARMv8 regarding this thing is that on the ARMv8, the monitor will be implemented by the trusted firmware and this BL31 stage, whereas on ARMv7, the monitor layer is really tied to the secure world. It's a single entity. So, for example, on the OPTI, when we use the OPTI on ARMv7, the monitor is part of the OPTI implementation, and OPTI provides its own monitor. So if SCMI server integration in the secure world has impacts on the monitor, then this has to be implemented also in the OPTI secure monitor. So currently, for example, we have those two mailbox we use, SPCI, right, SPCI, and this SMC-based mailbox. When we use the SMC-based mailbox, it's just SMC that goes through the monitor and reaches the secure world, so the monitor is not impacted. But for the SPCI implementation, then we have to change the monitor inside the OPTI so that it supports this SPCI specific thing. Sorry?
I'm trying to understand why can't the same approach that you use for the SMC mailbox be used for the SPCI mailbox as well?
Well, I would say that an SMC is raised from non-secure. It enters a monitor and then is dispatched to the secure world. Okay, yep. And wherever, well, if you use a TFA the runtime service from TFA that will get the SMC, and it will route it to the OPTI.
Yeah.
Okay? And if the monitor is in the OPTI, well, the SMC is just handled the same way. So there's no, well, whether you use the TFA BL32 or whether you use the OPTI monitor, the SMC is handled the same way. When you want to use SPCI, well, you know, TFA has to be adapted to handle SPCI. You have specific things to do when you dispatch a SPCI regarding a simple SMC that you just carried.
Sorry, I might be misunderstanding, but if you're talking about the secure world being entirely ARM v7, in that case, OPTI owns both monitor and the supervisor mode. So if you have a secure, when you say secure monitor, you're talking about the component that runs in the monitor mode, right? And that should be able to receive an SPCI SMC and dispatch it just like it does any other SMC. So the two bullets over there, that using the SPCI mailbox, there's a different behavior, and using the SMC mailbox, there's a different behavior. That's the bit which I can't seem to reconcile.
Sorry, I didn't catch exactly what you were asking for.
I'm saying that the two bullets that you have using the SPCI mailbox mandates SPCI be implemented in the OPTI secure monitor, the SM component, and whereas using the SMC mailbox, it can simply be routed into generic EL1. At the end of the day, both are SMCs, whether it's an SPCI SMC or whether it's any other SMC. So why is that distinction?
Okay, right. Maybe it's miswritten. Let's say that if we want to support SPCI, we currently have to modify the OPTI secure monitor, because it's a monitor. Currently, the monitor just gets a SMC. When it's an SPCI, it's not just a SMC identifier with some added arguments that are in registers, and you just propagate. With SPCI, you have to check who you target, where your messages. There are a lot of, well, not a lot, but there are few things to do that are quite specific and that are currently not handled by basic monitors that just gets a request, checks whether we have to enter which word, and just schedule the word and do nothing much with the message.
Yeah, so I guess that SPCI work in TFA BL31 will be happening at some point, and OPTI can just pick that up. Hopefully, maybe we could try to sort of modularize that and make it a library or something, so you can put it into OPTI more easily. I don't know. Maybe it's not that complicated. I don't know.
Maybe if the SPCI implementation is not that complex, because well, we have only to deal with few things. To have a really common code between the OPTI monitor and the TFA, whether it's a good idea or we can have separate implementations. That
we see that later down the line, I guess. We can figure that out.
And just one of the impact of modifying the secure monitor is that in the OPTI ARMv7, the secure monitor, if you run the OPTI on a memory constrained device, then we enable this OPTI pager thing, where we use runtime paging and page out of memory. And what's in the OPTI secure monitor is resident into this internal RAM. So the more you increase the size of the monitor, the more you reduce the size of the pool of the memory pool available to the pager. So, and memory is quite expensive at this stage. So the smaller it is, the better it is.
So that might help, you know, in this longer term picture where we have everything in TAs, then that might help then. Hopefully the core code will be smaller.
And I think it was the last slide. Oh, the next steps. Yeah, we're not finished. Well, I guess the next steps are all things we already discussed here, like sending some pull requests, making some changes, checking this SMC mailbox, how it helps. We have this notification thing that has impacts specifically in the Linux kernel. True. Check the memory size the memory footprint of the SCMI server. And,
Excuse me.
well,
You say how much read-only, but how much read-write memory?
Read-write, it's quite small, actually. Really, it's it's less than half a kilobyte. It's really small, but the read-only part is quite big, and it's really related to how the SCP firmware is built with these modularized things where you have tables and you have a lot of codes. So it's where maybe there can be some improvement in not using all the modules that are currently used by the SCP firmware, but maybe making some shortcuts and only getting the SCMI protocols out of the SCP firmware and less of the modules. But it's something we have to discuss with SCP.
There are some optimizations that we do intend to do in the SCP firmware itself. We know there are some places where it consumes more memory than required. So some of those optimizations will come in due time as well.
Okay, thanks.
I think we've been through it.
Maybe just a question more for Achin, but the notification stuff, is that something SPCI will look to address as well?
Yeah, like the last time I had a discussion with Shovik, you remember that, right? The conclusion was that we can get away with it, but if it's for at least SPCI v1.0, but if that's changed, then we should discuss that.
For the next version, we need it. For this version, yeah, we can still do without.
Damn. Okay, let's have a chat about that. Yeah.
Yep. And just following this session, there is a session on SCMI v2, some updates. Yeah, and on Wednesday, don't remember which time, I think it's 4 o'clock. Yeah, we have an open session. I don't know in which room. Is it a hacking room or some plain session thing?
Sunset 1 the whole day.
Okay, so it should be in the schedule. There's an open session about this SCMI server thing, just like a free discussion. Yeah. And there is also some discussion, some free discussions around the SPCI on Wednesday afternoon, I think, right after lunch.
Yeah, I don't remember the time, but it's in Sunset 1 as well, in the afternoon, yeah.
Any more questions or comments? Just feel free. I hope just the intentional was clear enough so that people understand what we want to do with the CMI and why using this secure world thing. Do not hesitate to come and see us if you want. Thank you.